Hello. Please hit like button and subscribe my channel. Also press bell icon for future video notifications. Thanks.
A satellite on a science mission to Mars aims for a low-altitude orbit, but the lower the orbit, the more propellant is required to enter orbit when arriving from Earth. To save propellant, a technique called aerobraking uses a small propulsive maneuver for orbit insertion to enter a large orbit. The satellite then makes many passes through the upper atmosphere, using drag on the solar panels to reduce the size of the orbit a little bit each pass until the orbit is. Aerospace engineers at the University of Illinois Urbana-Champaign developed a way to use articulated solar panels to steer the satellite during aerobraking, reducing the number of passes needed, resulting in potential savings in propellant, time, and money. If we can rotate the solar panels, we can control how much drag is generated, and we can actually steer during the atmospheric passes to control heating and energy depletion, said Professor Zach Putnam. This means we can fly much closer to operational constraints, and aerobrake much faster. Putnam's Ph.D. student Giuseppe Falconi used the satellite's ability to rotate their solar panels and calculated how the panels could be used to optimize and control the drag. Being able to steer the satellite during each atmospheric pass enables us to ensure we don't over-temperature the solar panels while flying much closer to the thermal limit. This is a big improvement. Instead of aerobraking for 3 to 6 months, it might only take a couple of weeks. This study is about automating just one pass through the atmosphere. This process would be repeated many times during a complete aerobraking campaign, Putnam said. He explained that as the satellite's orbit gets smaller and smaller, the time it takes to complete one orbit gets shorter until the orbits are so short that there isn't time to transmit information from the spacecraft to Earth, wait for a decision, then send commands back to make a correction. Because it is automatic, Giuseppe's algorithm is particularly helpful at that last stage when the orbits are very rapid, but the algorithm can be used for the entire process. This is the first piece toward developing an autonomous capability for aerobraking that has implications for reducing cost. And the trip out to Mars takes somewhere between 6 to 9 months. We can't really change that, but we think we can shorten the time it takes to aerobrake to a low-altitude orbit, Putnam said. You can imagine how expensive it is for a ground team working around the clock, he said. There is also limited bandwidth for ground stations that can talk to Mars. And it could be done by many satellites at the same time. Story source. Materials provided by University of Illinois Granger College of Engineering. Original written by Deborah Levy-Larson. Note: content may be edited for style and length. Journal reference: Giuseppe Falconi, Zachary R. Putnam. Energy Depletion Guidance for Aerobraking Atmospheric Passes. Journal of Guidance, Control, and Dynamics, 2021. 1 doi, 10. 2514/1. G006171. Cite this page. University of Illinois Granger College of Engineering. New control technique uses solar panels to reach desired Mars orbit. Science Daily. https://ift. tt. 3fuq mal. Access January 24, 2022. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.